Hello, everybody. Today's unit, we are going to be talking about water, electrolytes, and temperature regulation, and kind of the interplay between each of these factors as it relates to nutrition and exercise, and kind of how we can manage all of these aspects. So what is water? Water consists of a major portion of the human body. About 50 to 70% of our body is made from water, and this can be dependent on body composition. So the more fit you are, or the higher your muscle mass, the greater your water content. So lean muscle contains about 73% water, versus fat tissue contains a significantly lower portion of water. Only about 20% water is found in the fat tissue. So individuals that have higher muscle mass also have higher water content. Okay. What are the functions of water within the body? Number one, it can serve as a solvent. Number two, it's important for temperature regulation, which will be what we kind of focus on in this unit. Number three, maintenance of acid-base balance. Number four, it'll provide a medium for transportation. So for example, the cardiovascular system has blood, and most of the blood is made up of water. So it's going to serve as an excellent way for us to transport nutrients, waste, hormones, and many other factors. Water also functions to help remove waste products. So for example, in the urinary system, we'll use our urine, which is primarily made of water, to get rid of waste products. It will help us to lubricate our joints. So we have synovial fluid found in each of our joints, and that's going to be an important element for us to maintain joint health and maintain a pain-free ability to move. And then lastly, it will function as bile, saliva, amniotic fluid. Okay, so bile is a liquid that's going to help us to break down fats. Saliva is going to help us to be able to absorb nutrients so that we can taste them, and also helps us to break down carbohydrates. And then amniotic fluid is going to be like a fluid that's going to be in mom's tummy, and this will serve as kind of like a shock absorber for a growing fetus or growing baby. Okay. So here you can kind of see how the total body water volume is kind of split up. So we have intracellular fluid volume, which is about 40% of our body weight. We have interstitial fluid, which is about 80% of our extracellular fluid. And we have plasma volume, which is about 20% of our extracellular fluid. Okay, so we have intracellular. Intra means inside of the cells. Extracellular fluid means outside of the cells. And some of that will be in the form of interstitial and plasma volume. So intracellular and extracellular fluid levels can vary based on several factors. Number one is body composition. Okay, so an increase in body fat will decrease your body water. Okay, so again, as we mentioned, adipose tissue or fat tissue doesn't store very much water. So if I have a lot of fat tissue, I have not a lot of water within the body. Okay. Number two is carbohydrate content. So carbohydrates are going to be water loving or hydrophilic. Okay, so they're going to pull water with them. So for every one carbohydrate molecule that you store, you also store two water molecules alongside of it. Okay, so essentially what happens is when I pull carbohydrates out of storage, I also release two water molecules kind of at that same time, because those two water molecules were kind of stored with those sugars. Okay. And then number three, electrolyte concentration. So electrolyte concentration inside and outside of the cells will determine kind of the pull of fluids. So for example, if I have a lot of sodium inside the cell, water will want to be around the sodium. So sodium is also hydrophilic or pulls water. It's water loving. So wherever I have sodium, water will also follow. When we think about water movement, the movement of water is generally based on ion or electrolyte movement. So what is an electrolyte? An electrolyte is a molecule that provides us with charge. And in this case, they're considered electrolytes. They can conduct an electrical current. So these are going to help us to generate electrical currents in the nerves and the muscles, which allow these types of cells to be excitable or stimulated. Okay, so some of our electrolytes that are important within some of these areas, including the nerves and the muscles, as well as cardiac tissue as well, Sodium, potassium, chloride, phosphorus, magnesium, and calcium. So by controlling the movements of these molecules in and out of the cell, we can control appropriate amounts of water in each of these compartments as well. So I gave the example that sodium is very, very strong at pulling water. So if I have a lot of sodium in one particular location, it will also pull water in that way. Okay, lots of our cell walls are what's called semi-permeable, and basically that means like some things can fit through, but not everything can fit through. While these molecules are not usually able to like cross freely across membranes, the water is able to move freely across these membranes. So basically, like the water will just kind of go wherever these molecules are that it like wants to be around. So let's start by taking a look at sodium. Okay, so the symbol for sodium is Na. It's actually an Na plus because it provides us with a positive charge. Okay, here you can see some of the recommendations. Um, we have the upper limit, or the upper tolerable intake level is highest level of daily nutrient intake that's likely to pose no risks of adverse health effects. We have the daily value, or DV, and this represents how much of a specific nutrient you should obtain in your diet based on a 2000 calorie diet. Okay, so notice the difference here in these values, and also of importance is to note that generally people overconsume this nutrient. We have sodium in so many different foods that we consume, including lots of processed foods. So again, it's very easy for us to overconsume this. So how do we reduce our sodium intake? We can drain and rinse our veggies. We can use different spices that don't have a lot of salt on them in order to kind of substitute in for the salt. And again, I think another factor that's important is just making sure we're hydrating with plain water and drinking enough water to kind of counterbalance. What are the major functions of sodium? Again, we've talked about this briefly in our last lecture, but primary goals or primary functions of sodium include being the principal electrolyte for extracellular fluids. So again, as I mentioned, water really wants to follow sodium. And this is going to be critical for nerve impulse conduction and muscle contraction. It's also going to help us to maintain normal body fluid balance and osmotic pressure. And it's essential for control of blood volume and pressure. It's a component of sodium bicarbonate, which is going to help us to maintain the acid-base balance, or the level of acidity within the blood. And it could also provide us with some potential ergogenic effects, which means like it could help us to improve our athletic performance potentially by consuming in appropriate amounts. What happens if I have a deficiency of sodium or excess? Okay, so sodium is critical for lots of factors within the body, and we have control of this within we have control of this within the hypothalamus, which is a section of the brain. And basically, like, we'll try to either hold on to sodium or retain the sodium, or get rid of sodium if we have too much. And we'll do that through like the urinary system. So within the urinary system, we can either hold on to the sodium because we're maybe low, or we can get rid of it in our pee if we like have too much. So the next electrolyte we want to take a look at is chloride, and the symbol for chloride is Cl. You can see here, and we can see that this is actually a major negative ion in the extracellular fluids. Common table salt is 60% chloride, so it's sodium and chloride included in that. And here you can see our daily value as well as the upper limit here as well. Food sources, variety of food sources, dietary intake closely associated with sodium. So again, most of the times when we are consuming sodium, we're also getting chloride. So what are the functions of chloride? It's going to work closely with sodium regulation of body water balance, electrical potential across cell membranes, and it helps to form hydrochloric acid in the stomach, which is an important enzyme that's going to assist in the breakdown of proteins as part of that digestive process. So what about deficiencies of chloride? These are super rare. Again, this is possible when we experience like heavy sweating with losses of sodium. So again, think like heavy exercise in hot and humid environments. That is certainly possible in those conditions, but otherwise, just for your average day, not usually a big concern for us. Excessive consumption of chloride can increase blood pressure. It can cause a buildup of fluid in people with conditions such as congestive heart failure, kidney disease, and cirrhosis, which is liver failure. So again, those are some of the individuals that need to kind of keep that in mind. But certainly if we're over consuming sodium, it is certainly possible that we're also over consuming chloride. Okay. Let's take a look at potassium, and the symbol for potassium is actually K. This is a positively charged molecule, and our daily value is 3.5 grams. Note that that's less than our average intake for the average person. Food sources, most foods, it's especially abundant in fruits, vegetables, meats, and milk. Bananas are supposed to be a great option for for potassium consumption. But many fruits and vegetables also are going to be high in potassium. Major functions, it's going to work with sodium and chloride to maintain body fluid balances. It's also important for the nervous system. It's going to help us to send electrical impulses. It also plays a role in energy production. Okay, so it's going to help us to transport glucose into the muscle cells. It can help us with the storage of glycogen, and it's the product of high energy and the production of high energy compounds. So it is going to be very important with energy production, particularly related to sugars. So what happens when we have a potassium deficiency? So deficiencies and excess are rare. So like sodium, potassium balance is regulated by the hormone aldosterone, but in the reverse way. So if we have a high amount of potassium, it'll stimulate aldosterone release. Aldosterone will increase excretion of potassium in the urine. So again, it's rare that we're like out of balance with this, just because we have hormones in place that are monitoring this and making sure we're keeping it within the normal ranges. So let's think about body temperature regulation and the application of electrolytes and fluid to maintaining our body temperature. So we know that water temperature changes slowly because it has a superb ability for us to hold heat. So water serves as an excellent medium for us to transport heat. Because water requires much energy to change states, it's an ideal medium for moving that heat. Okay, so this can allow us to have heat conservation, which means we hold on to our heat, or heat dissipation, which means we're sending the heat to our skin surface so that it can be removed from the body. Okay. So here you can see the difference between what's known as the core and the shell. And the core is shown here in red, and the shell is shown here in this like light purple area of the body. Now, during cold conditions, we keep all of the heat or the blood at the core, which means our core temperature stays at 37 degrees. The shell temperature is much more variant, so it can be like significantly colder in comparison to the core. In a hot environment, the core expands. So basically, we're going to send blood to all these areas of the body so that we can spread that heat out. And the closer that heat is to the skin surface, the more likely it is that we can get rid of it. So we'll expand the core, sending blood to the skin surface in order for us to potentially get rid of the heat that we have. So the body temperature is regulated in 4 ways. So heat can be dissipated via 4 mechanisms: conduction, convection, radiation, and evaporation. Additionally, when food is broken down into energy, 60% of those calories that we break down are lost as a form of heat, and only 40% is converted into useful energy. just like when a car runs or like you have a treadmill going or something along those lines, we're producing heat as a byproduct of regular metabolism or regular work. And so again, we see that not only in humans, but in animals and in machines as well. So when we think about balance, right? So we're thinking about how do we balance our heat? So H equals heat balance, okay? Here are the factors that we must consider, okay? Um, the following are going to give us heat. So resting metabolic rate, work done, both of those two factors are going to provide us with a positive amount of energy, okay? Conduction can be a heat dissipator or a heat gain. Same with convection and radiation. They can either get rid of heat or bring heat in. And then evaporation is always negative. Evaporation is only going to allow us to lose heat. Okay. So again, it's really the sum of all of these elements that will determine our heat balance and whether we are getting hotter, if we're getting colder, or are we remaining the same. So, like, what's up with that? So, some of these factors can give us heat, some of these factors can get rid of heat, and some can do both. Okay, so body temperature is regulated through the control of the hypothalamus. The hypothalamus has like a thermostat basically, and it's going to receive input from receptors in the skin that tell us if we're hot or cold or what's the environment around us like, and also within the blood. Okay, so we have temperature sensors found in the blood, and that's going to measure our blood temperature and tell us like if our blood's getting too hot or if our blood's getting too cold. Okay. Output. Okay, so we have circulatory system compensation. So when we're hot, the circulation to the skin will increase so that we can get the heat closer to the outside and radiate it from the core a little bit easier. So the closer we can get that heat to the skin surface, the more likely it is that we can get rid of that and dissipate heat. Okay. When we cook, I'm sorry, when we're cold, if I can read my notes here, circulation to the skin decreases to direct flow to the core. This causes a decrease in heat loss by radiation and keeps our vital organs safe. Okay, so again, instead of sending blood to the skin surface, we want to keep that blood at our core, and that's going to allow us to maintain temperature at the core. Okay. Muscle contraction, so shivering is muscle contraction, and this can create heat from metabolic work. And then sweating. So sweating, evaporation of sweat allows us to carry heat away from the body. Water can help us remove waste products as well. So most unstable surfaces in the body dissolve in water and exit through the urine. We'll get rid of urea and sodium. We typically produce about 1 liter of urine per day. Heavy ion concentrations in the urine increase our risk of kidney stones. Again, somebody that's just kind of like chronically dehydrated would be at higher risk for kidney stones. So again, probably another reason why staying hydrated is so important, making sure we're drinking plenty of fluids. How much water do we need? How much water do I need to stay hydrated? We need about 1 ml of water per calorie expended. Okay. We generally consume about 80% of our water from fluids, about 15% from foods, and then about 5% is formed during metabolism. So again, I told you that sugars were stored with water. So like 1 sugar molecule is storing 2 water molecules. So as I start to use those sugars out of storage, it will release or liberate water. Water is also produced from like the CO or from the oxygen that we use within the aerobic pathways as a waste product. So about 5% of our total water in the body is coming from some of these metabolic pathways. Okay. Water intake, generally about 1 to 2 liters per day or 50 fluid ounces is reasonable. 48 fluid ounces coming from other beverages, so about 1.4 liters from other beverages like coffee, juices, pop, milk, etc. Okay. This can vary depending on body weight, also which stage of their life cycle. Again, very common for kids and adolescents to drink a lot of milk. I can't tell you the last time I've had a glass of milk. It's probably been, I don't know, 20 years, maybe more than that since I've had a glass of milk. So, that certainly has changed. I certainly am not afraid to have a glass of wine though. So again, you see some of these fluids changing throughout our lifespan. Okay. Under normal conditions, again, like we said, we need about 1 ml of water per calorie of energy. So for women, that's about 8.5 cups per day. For men, it's more like 12 cups per day. This I just thought was interesting. I just pulled these from online, but this just shows you the water percentages for some of these fruits and vegetables. Again, freaking look at the greens on here. I can't sell them enough to you. When we think about fruits and vegetables and all the benefits they provide, a cucumber, 96% water, blueberries, 95% water, a pear, 89% water. So again, a lot of great options here. Here's another chart that I found that kind of shows you some of these. So we've got celery, cantaloupe, tomatoes, blueberries, pears. So again, a lot of great options here in terms of water content, in terms of hydrating foods. I don't usually like, especially in the winter, I don't really like drinking water. I drink coffee, I'll drink tea, but I'm not really like driven to drink a lot. But maybe, trying to get a lot of these foods is a good option or a good alternative for people like me that are just not really like big water drinkers. I'll drink other things, but I could do a lot better to drink. And so maybe this would be a good supplement. Water loss, how are we losing our water? We're going to lose about 1 liter uh, per day from urine, about 500 mils through respiration. So again, each time you breathe out, if you breathe out on a window, you'll notice that it gets foggy, and that's because you're breathing out fluids as well. So that fogginess is coming from the water molecules in your breath. About 150 mils through our feces or our digestive tract, and then 500 mils through insensible perspiration, which is sweating like without knowing that you're sweating, basically. So again, we're constantly sweating. You're constantly putting moisture on your skin surface, and the air around you is collecting that. So like, for example, if you live in Iowa or the Midwest, okay, um, in the winter, it's super common to get dry skin. And the reason that your skin gets dry and itchy is because the air is dry. And when the air is dry, it's more likely to grab this perspiration off your skin surface, which causes your skin to get dehydrated. Okay. I'm recording this lecture on a hot and humid day in the summer in Iowa. And again, I can put a lot of sweat on my skin surface, but not all of it will be accepted because the air around me is so humid. So the more moisture that's already in the air, the less likely the air is to accept those molecules off of your skin surface. So while in the winter, I need to put lotion on probably twice a day, especially my hands get very cracked. In the summer, I never put lotion on, okay, unless it's sunscreen. So again, that's not a big concern because that moisture stays and sits on top of our skin surface in the form of insensible perspiration. So again, the ambient temperature or the temperature around you, the conditions around you, will in part play a pretty important role in determining kind of what's going on with the skin in terms of its hydration status. So we know that thirst is not a reliable signal for water needs, particularly during vigorous exercise for infants and older adults. So if you wait till you're thirsty, you probably waited too long. So it's important that we make sure we're consuming plenty of water on a regular basis and not waiting till we get thirsty to need it. So what if thirst is ignored? Okay, so again, if we're thirsty and we haven't been drinking, what happens next if I don't drink? Okay, so if the body registers a shortage of water available, it'll increase its fluid conservation. Okay, and the decrease in fluid will cause a decrease in blood pressure, which is going to stimulate the release of two hormones. Number one is ADH, or antidiuretic hormone. And antidiuretic hormone's job is to conserve water within the kidneys. And number 2 is aldosterone. And aldosterone's job is to conserve sodium, and hence it'll pull water along with it. So again, both of those 2 hormones are going to increase, which causes us to then hold on to or retain that water that we already have. What happens if we lose too much water? So if we have 1 to 2% fluid loss, this will cause us to feel thirsty. And again, imagine if you're 200 pounds, that's 2 to 4 pounds of weight, basically, or of water that you've lost. Okay, a 4% loss, muscles will lose significant strength and endurance. A 10 to 12% loss. So, for example, if I'm like about 120, 125 pounds, so if I lose 10% of my body weight, that's 12 pounds. That's a lot when you only weigh 120 pounds. Okay. So again, heat tolerance will be significantly decreased, and weakness results. A 20% loss will be result in heat related illness and could potentially lead to heat stroke and death. Can certain beverages, foods, and medications contribute to fluid loss? The answer is yes. Okay, so coffee, alcohol, soy sauce, processed salty meats, popcorn, fried food, fizzy sugary beverages, and asparagus will all contribute to fluid losses for us. So again, it's important to kind of note that if you're consuming those, and make sure we're consuming water to kind of balance that. They have this cute idea of like for every beer you drink or every alcoholic drink that you drink, you should alternate with a full glass of water or the same amount of water in order to kind of prevent that dehydration process. So again, something to kind of think about there. Can I overconsume fluids or underconsume fluids? And the answer is yes to both of those questions. We can overconsume and we can also underconsume. So it's important for us to balance. Again, in my, dare I say, 20 years of working in exercise physiology, I have never seen someone overconsume fluids personally in my athletic experience. I have often seen someone underconsume fluids. Okay, so it's very easy for us to get dehydrated. It would be rare for us to overconsume water. So what happens if I overconsume water and just plain water? This can cause a condition known as hyponatremia, which is basically low sodium levels. Okay, so it's an electrolyte disturbance in which sodium concentration is lower than normal. A lack of sodium is rarely the cause of hyponatremia. In 2002, at the Boston Marathon, 13% of athletes experienced hyponatremia or a hyponatremic state. And the reason is not because they didn't consume sodium. It's because they consumed a lot of plain water and didn't include electrolytes in their beverage choices during this particular race. So what are some risk factors for developing hyponatremia? Okay, so you need to do exercise over 4 hours at a slow pace or a low intensity. Females are more likely to develop hyponatremia in comparison to males. They will also be small females, so low body weight. They're excessively drinking. They're going to overhydrate during pre-exercise. So again, if it's the Boston Marathon, for example, they're overhydrating before they get to the start of that race, and then while they're in the race, they're also over consuming drinks. Okay. There's an abundant availability of fluids during the event. So for example, the Boston Marathon, so a marathon is 26 miles, 26.2 miles. And the Boston Marathon is a point-to-point race. So you start in Hopkinton, which is like the west side of Boston, and then you run 26 miles into town and finish in downtown Boston. And essentially, like the streets are like lined with fans. There are people the entire time you're running, and there's fluids everywhere. Like there's little aid stations where you can get fluids like the entire time. So there's an abundant availability of fluids at the event. Okay, every mile, every 5 to 10 minutes, you can get fluids. And again, that's probably too much. If somebody is taking fluids at every single aid station that there is, that's probably overdoing it. Okay. They've taken some like anti-inflammatory drugs like ibuprofen. Maybe their hip's been bothering them, or they have a hamstring issue going on. So they're going to take some ibuprofen before the race starts. and then they're experiencing either extreme hot or cold conditions. So, unfortunately, what are the consequences of hyponatremia? So, you're going to have confusion, seizures are possible, altered mental status, impaired renal function, respiratory distress, so kind of like hyperventilating, headache, vomiting, and edema, and potentially death. Now, what's scary is the consequences of dehydration aren't really that different. So it's really important that, we're aware if you're going to be an athletic trainer or work in a medical field, that you understand hyponatremia is certainly possible under these circumstances. So it's important that we understand that and kind of pay attention to that. Like I said, dehydration, much more of a problem, much more commonly an issue for us. So exercise performance is decreased when as little as 2% of our body weight is lost. Okay. So again, if you're 150 pounds, 2% is about 3 pounds. Okay, so 3 pounds is pretty darn easy to lose. I already told you I'm like 120, 125 pounds. Pretty easy on a hot and humid day. Like this morning I ran not quite 9 miles and it was humid and muggy and I was really sweaty. I probably lost over 5 pounds in that particular run. So it's very easy in hot and humid environments to lose a lot of body weight. Okay. Losses in excess of 5% of body weight can decrease work capacity and endurance performance by 30%. For sprint athletes, up to 45% loss with as little as 2% body weight reduction. Even in thermoneutral environments. So this means that even in not hot and humid environments, VO2 max decreases by 5% when fluid loss is 3% of total body mass. So even if I'm just sweating at a pretty good rate because I'm working hard, I'm still losing quite a bit of fluids and this can negatively impact me. Okay, endurance performance will be severely impacted by dehydration. Exercise in the heat will be impaired to a greater extent in comparison to exercise in a thermal neutral environment. And that's because heat is going to be more dangerous for us. And so therefore we're going to sweat more to try to get rid of the heat and therefore put us at a greater likelihood to experience dehydration. So what are some of the consequences of dehydration? Okay. So basically what's going to happen is we're going to see a decrease in plasma volume, which is the fluid inside of our blood. And that's going to make our blood, so that's here, that's going to make our blood thicker, more like a milkshake. Okay. And that causes a decrease in the total amount of blood that we have and a decrease in the amount of blood that returns to the heart. And basically what happens is our heart rate is going to skyrocket. Okay, so when we're in a hot environment, our heart rate is working really, really high, and our blood becomes more like a milkshake. So it puts more strain on the heart as well. Okay. So again, consequences of dehydration can be the result of a negative water balance. So I haven't consumed as much water as I've lost. It can cause overheating, an increase in cardiovascular stress, can cause muscle cramping, a decrease in metabolic efficiency, which means like it's harder for us to like break down calories and use them, reduced blood volume, decreased skin blood flow, decreased sweat rate, decreased heat dissipation, increased core temperature, and increased rate of muscle glycogen usage as opposed to the usage of fats as a fuel source. So what should we do in order to hydrate during exercise? If this is a big threat for us, we're looking at, this balance issue. Okay. So water and electrolyte losses during exercise can vary greatly depending on several factors. Number one is environmental conditions. Our biggest threat is hot and humid environments. Number two is the mode of exercise. So again, running's kind of like the most challenging because it burns kind of like the most amount of calories in a hot environment. Or I shouldn't say the most, like football would probably be worse because you're wearing the helmet, and that's going to kind of retain heat. So that can certainly be a problem. But something like cycling, where I'm moving through the air, I get more of a wind flow. So cycling isn't as bad in comparison to like football or running, something like that. Training status. So like if you're not well trained, it's going to be more problematic for you versus somebody who's highly trained. Body composition and body size. So again, a lower body fat percentage would be better for us because you're going to have more water to start with. And then gender as well will play a role. Okay. So for slow paces, we need to get about 16 to 20 ounces of fluid per hour. In a hot and humid environment, fluid loss can be up to 2 to 3 liters per hour. Can you imagine trying to drink 2 to 3 liters in an hour? That would be insane while you're exercising. Okay. So again, in a hot and humid environment, it is pretty much impossible for you to stay ahead from a fluid perspective. Okay. For short duration exercise, water is good enough, but during longer duration exercise or at high intensity, we also want to make sure we're taking in electrolytes as well. Okay. In order for us to replace what we've lost in our sweat. So sweat rates can vary significantly. Sweat rates are almost twice as much for males in comparison to females. Okay. So there's greater regional and gross sweat rates of aerobically trained males in comparison to females. Research has shown that. Factors that influence sweat rate, again, air temperature, relative humidity are both very important. Those are probably the two most important: wind, the clothing of the individual, genetic predisposition will also play a role, heat acclimatization. So again, like 80 degrees in August isn't really a big deal. 80 degrees in April is a very big deal because we're not used to it. So again, keeping that in mind. Okay. Children may sweat somewhat less than adults. So again, kids aren't as good in those hot and humid environments. Okay. Sweat rates may be as high as 2 to 3 liters per hour, which could result in 6 to 9 pounds of water, which is nuts. Most athletes lose less, about 2 to 3 liters per hour when exercising in the heat, but some athletes could lose up to 22 pounds in multiple daily workouts, which is nuts to imagine swinging your weight 20 some pounds. That's a lot. Factors that influence sweat rate, again, environment and individual characteristics are both going to be important. Where does the sweat come from? We have two different types of sweat glands. So we have apocrine sweat glands and eccrine sweat glands. The apocrine sweat glands are going to secrete like an oily mixture, and these are going to be in hairy areas of the body, like such as your armpit, like genital area. These are going to have an odor as well. The sweat that comes from the apocrine sweat glands is going to have an odor. We are sweating from these sweat glands when we get nervous. Okay, so again, if you're nervous or excited or upset, any type of emotional stress will activate those apocrine sweat glands. Okay, the eccrine sweat glands, we have 2 to 3 million of these over the surface of the body, so they're kind of all over the place, and their primary job is temperature regulation. They're going to be more of a clear substance. They're not going to be oily and smelly. It's just going to be primarily water. You'll certainly have some electrolytes in there as well, but sweat from the eccrine sweat glands is mostly water, about 99%. Some of the other items that will be found include sodium chloride, potassium, calcium, iron, zinc, a little bit of amino acids, and some vitamins as well. Okay, so very important that we are refueling those, but this can serve as a way for us to get rid of waste products as well. Again, when we think about that composition from the sweat from the eccrine sweat glands is mostly water. Sweat composition can vary after acclimatization. So again, the longer I've been in the heat or the more often I become sweaty, my sweat will become more watery and less electrolyte-y. So again, that would favor us being able to like reserve our electrolytes and get rid of just the fluid. Okay, and it's also going to enhance our ability for that sweat to be evaporated into the air. Okay. Meyer and colleagues reported that increased sodium and chloride and decreased potassium in sweat when we looked at males and females compared to pubescent and prepubescent boys and girls. So we know that age will play a role. Higher sweat lactate and ammonium concentrations were in boys and girls compared to adults. So again, we can understand that, age will play a role in what's happening with our sweat as well. Okay, and lastly, will sweat lead to an electrolyte deficiency? Possibly. So during exercise, serum electrolyte concentration normally increases in the exercise as sweat is hypotonic to the blood. Serum electrolyte imbalances may occur with improper fluid replacement. And we know that during exercise, electrolyte losses should be replaced, or a deficiency could occur over time. So again, if we're not able to consume those molecules while we're exercising, it's important that we try to get those in, whether that's from food sources or from some sort of supplement like Gatorade or an electrolyte drink, in order to kind of compensate for that after the fact, right? And that, my friends, is all we have for today. I hope you have a great day, and we will see you next time.